Okay, so today we are going to learn about converting decimals and fractions between each other. Alright, so we're going to convert between each other. A couple of little things that might make things a bit easier. When the denominator is 2. When the denominator is 2, think halves. What is a half as a decimal?
0.5.
0.5, right? So
Denominator is what? 17.
So 0.5 is a half as a decimal. Okay. Next one. When the denominator is, I'm just going to use the dittos, 4. You can write that out properly if you like. I'm just using dittos. When the denominator is 4, we think quarters. What is a quarter as a decimal? 0.25. Yeah? Are we good with that so far?
Yep.
And some more dittos. If it's 10, we're going to think tenths. What is a tenth as a decimal? 0.1. Okay, so that's just a way of getting some basic ones in your head ready to think about. Okay? Does that make sense so far?
Yeah.
So this is just a little bit of a concept, some basic ones that help us out. Okay? We all good with that?
Yeah.
Alright, let's look at some examples. Example 1. So we're going to convert a whole bunch of decimals, and then we're going to convert back the other way. So let's do the 2 for now. We have 0.239 and 10.35. Alright, and we want to go into simplest form. Okay? So let's look at the first one. Have I got any whole numbers?
No.
No whole numbers, I'm just going to have a fraction. So, I'm going to put in my fraction bar, or vinculum, as it has otherwise been called. 239 is going to be on top. Who can tell me what might be on the bottom? 1,000. Because we did that with place value the other day, didn't we? So, we've got tenths, hundreds, thousandths.
Oh, so how many
So
places?
now we have 1,000.
So many things.
Yeah. Right? 3 decimal places, 3 zeros. Makes that easy, doesn't it? Any questions? Now this one is as simple as it gets. You can't actually simplify this one because there's no common factors. So this is where we need to find our highest common factor. Next one, B. 10.35. Do we have whole numbers?
Yes.
We do have a whole number, we have 10. So 10 is going to be on its own. Don't need to do anything else with the 10.
35 and 10.
And then we have 35 over what number?
100.
100. Awesome. Alright, 2 decimal places, 2 zeros.
10 and 35.
Okay, now 35 and 100 don't have any common factors.
Yeah.
What might be a common factor with 35 and 100?
10.
Not going to be 10 because that ends in a 5.
5.
It's going to be 5. How many 5s go into 35?
7. 2.
7.
7.
Right, because we're going to have the highest common factor of 5. So we divide everything by 5. What's 100 divided by 5?
10. No, 20.
20.
I have the thing.
And now we're at our simplest form.
720.
Okay? So we're going to convert these following fractions to decimals. First one's pretty easy. We've got 17 over 100. Alright, we've got 17 over 100, that's 17 hundredths. What is 17 hundredths as a decimal?
0.17.
0.17. That's easy, isn't it? Yeah, pretty easy that one. This next one's a bit trickier. We know we've got a whole number. Whole number's 5.
5 and 6.
So we're going to have 3 over 5. What's 3 over 5 as a decimal?
That would be 0.6.
0.6. Because this is also equal to, this is why it's really important to know about equivalent fractions. That has all the same values. So if we go 6 over 10, that's going to be 0.6, isn't it?
So 0.6.
Yeah? So 5.6. Because 3 over 5 is the same as 6 over 10.
That is intelligent.
6 over 10 is 0.6. So it's really good to make those connections early and make sure that we're making those links. 7 over 12 is a little bit trickier again. Alright? There's no whole numbers, so we're going to end up with a 0 point. But here's the tricky bit. This is a skill that you're going to need to be able to do. 7 over 12 can also be said to be 7 divided by 12.
But isn't the
Because what does a fraction kind of look like?
divided thingy? But isn't the line the divided by symbol?
Fraction kind of looks like a divide sign, doesn't it? Or a divide sign kind of looks like a fraction. So that's what's actually happening. So we've got 7 divided by 12. Right, so we can go 7 divided by 12. We can write that algorithm out. Come on. 12 into 7. Is that the way around it's supposed to go? Yes. Now I'm going to have to put in a whole bunch of zeros because 12 doesn't go into 7, does it? Not with a whole number answer. So we're going to end up with a 0 point up here. What about 70? Does it go into 70?
Yes.
How many times does it go into 70?
7, 3, 8. No.
Someone said 5?
5.
Good, because that's the answer.
100.
How many 12s, or how many is left over from 70 once we've done 5 12s?
12.
So 5 12s is 60, isn't it? What's left over from 70?
12.
So what's the difference between 70 and 60? 10. So we need to put in 10.
Wouldn't it be a 1?
Alright, no, it's 10.
Sure.
Because there's 10 left over. Yeah?
Yeah. Okay.
Right, there's 10 left over, so we've got to add 10. But because it's 0, it still becomes 10. Are there any 12? How many 12s go into 10?
None.
None. How many 12s can go into 100?
Heaps. A bunch.
A
bunch. 8.
Because we're going to add this 10 and that 0. So there's going to be 2 zeros, so it's going to become 100. So we're going to have 8. So that 10's in the wrong spot, sorry. Alright, so we're going to have 8. What's left over when we've times 8 by 12?
4.
4. How many 12s go into 40?
3.
3 with how many left over? 4. Because 3 12s is 36. And we've got the same thing again. So that's going to happen again. And then it's going to keep continuing. So it's going to be 3 on repeat from here on out. So what we're going to do is we're going to say that it's 0.583. What can we do to suggest that 3 keeps going?
It goes on a little infinity sign.
Not a little infinity sign, just a little dot. That little dot is what we call a repeater sign. So if you see that little dot, that means that number just keeps continuing. If you see it over two numbers, those two numbers as a pattern keep continuing. Okay? That's the tricky one. That's one that's you're probably going to struggle a little bit with, and that's okay to struggle at the start. Just follow your processes and you'll be okay. Are there any questions about this stuff? Awesome.